We're going to be going over these notes for section 12.2, angles and angle measure. So I'm going to be telling you what to fill in on the lines, okay, and explaining it along the way. An angle on the coordinate plane is in the standard position if the vertex is at the origin and one ray is on the positive x-axis. So for this lesson,
What were the planes?
an angle on the coordinate plane is in standard position if the vertex is at the origin and one ray is on the positive x-axis. So for all of these angles that we're going to be working with today, we're going to put them on the coordinate plane. So the standard position angle, the vertex is at the origin and one ray of the angle is on the positive x-axis. On the next sentence, the ray on the x-axis is called the initial side of the angle. It's the initial side because that's where it starts. That's your starting ray always for a standard position. The next sentence, the ray that rotates about the center is called the terminal side. It's the terminal side because that's where your angle stops. And looking at the next box, if the measure of an angle is positive, the terminal side is rotated counterclockwise. So let's look at example 1 to illustrate that. Draw an angle with the given measure in standard position. Okay, so first, I know you guys don't have protractors with you, so we're going to just estimate the best that we can these angle measurements. You know, they need to be realistic and as accurate as possible, but I don't expect them to be perfect, okay? Before we draw this angle, we're going to go around and assign an angle measurement for each axis. So these two lines being the coordinate plane, x and y axis, they're perpendicular to each other. So what kind of angles do perpendicular lines make?
90.
90. So all of these angles are 90-degree angles. Okay, so if I were to assign an angle measurement for each axis arm or leg, I'd start at 0 here because that one's it's a flat angle. There's no increment. And this next one is going to be 90 degrees. This arm would be 180. What would the next one be? 270, yep. And then the last angle, if it goes all the way around, 360 degrees. Right, it makes a full circle, that's right. Okay, so they want me to draw an angle with the given measure in standard position, 80 degrees. So I'm going to estimate where the terminal side of that would be a little bit before the 90. Okay, and then I want to draw an arc starting at the initial side and draw an arrow showing which way you're moving the arm, and then that's going to be your 80-degree angle. So positive angles always go counterclockwise. On that second sentence in the box, if the measure of an angle is negative, the terminal side is rotated clockwise. So for example B, negative 105, you always start with this initial side because the angles we're going to draw in this section are going to be in the standard position. So we're always going to start with the same initial side. Okay, but this time it's negative 105. So when you draw your angle, you're going to go past that 90-degree mark, and it's going to be about 15 degrees more than that. So I'm just going to estimate, and then I'm going to draw my arc, the arrow, and that's negative 105 degrees. Positive angles go up from the initial side, and negative angles go down from the initial side. Any questions? Okay, on the next example, it says draw an angle in standard position that measures 600 degrees. So to show an angle that's bigger than all the way around the coordinate plane, I'm just going to make it into a spiral. I'm going to draw my XY axis, and I'm going to write down my measurements again just to help me remember. So if I go all the way around once, I want to start kind of close to the center, because I'm going to make it spiral out. So if I go all the way around once, that's 360. 360 plus another 90 is going to be 450. Plus another 90 is what? 540? And I want to get to 600, so I've got to go just a little bit more past that, about 20 degrees. No, 60 degrees, wouldn't it? 540 to 600, that's 60 degrees. So I'm going to make it a little bit bigger. And there's my terminating side. And then we can label it 600 degrees. Okay, any questions? So anything that's past 360, you just want to make it into a spiral as many times around as you need to go. All right, let's look at the other side. Side number 2. 2 or more angles in standard position with the same terminal side are called coterminal angles. They share the same terminal side. Exercise 3 says to find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. So to do that, like on A, it gives you angle 15. So to find a positive angle that has the same terminal side, I'm just going to add 360 degrees. And a coterminal angle for this would be 375 degrees. A positive coterminal angle. And to find a negative angle, I'm going to subtract 360. And that would give me negative 345 degrees. So those two angles share the same terminal side as a 15-degree angle. So you guys go ahead and do B. Find a positive measure and a negative measure that are coterminal. And I'll do it up here. Is everybody good? So last Friday, one of the things you had to do is you had to make sure that your calculator was not in the radian mode. Okay, so this is what a radian is. And angles can also be measured in units that are based on arc length. This is called a radian. R-A-D-I-A-N-S. So we're going to be measuring angles with degrees and with radians, going back and forth. To convert, you don't have to change your calculator to radian mode. You can keep it in degree mode right now. We're not going to use it in the radian mode yet. So the next part is telling you how to convert from degrees to radians, radians to degrees. To convert degrees to radians, you're going to multiply the degrees by pi over 180 degrees. So on example 4, gives you part A is 120 degrees. They want you to change that to radians. So I'm just going to put that over 1, and then times pi over 180 degrees. Radians will always have pi in the answer. Okay, Okay, so I'm going to put pi there. And really the only thing I need to do is simplify the 120 divided by 180. So you could use your calculator. 120 divided by 180. Get your decimal value and then change it to a fraction. It's 2/3. So you'd write it as 2 pi over 3. It's 2/3 of a pi. Now, on the other hand, when you're changing radians to degrees, we're going to take the radian measurement and multiply it by 180 over pi, so it's really just the reciprocal of your other fraction. So on part B, we're going to take negative 3 pi over 8 and multiply by 180 over pi. That way your pi's reduce out, because when you're measuring in degrees, there's never a pi in your answer. And then just multiply your two fractions together. So for this section, it's okay if you have a decimal for your degree. Now later on we might change that to you need to have fractions, but for this section, introducing everything, it's okay to have it as 67.5 negative. Any questions? Okay, so on the next page, top of the page, all of the angles that we've been working with so far have been central angles. A central angle of a circle is an angle with a vertex at the center. All of the angles have been central because all of the vertices have been at the center of the coordinate plane. Okay, so we're going to talk about the unit circle here just a little bit, because you're going to be needing to know how to convert back and forth from degrees to radians. So we're going to go over the most common angles that they use. You might want to add this at the bottom of your notes where you have a lot of room, but just start out with the coordinate plane. And I'm going to label all my axes just like we did before, with 0 degrees, 90 degrees, 180 degrees, 270, and 360 degrees. And since we're measuring like how long the arc is, that's what we're going to be doing for some of this, I'm going to go ahead and draw a circle all the way around it. The center part is at the origin. And for the sake of argument, just to make it the simplest graph that we can make it, let's say that the radius from the center to the circle is 1. Okay, so we're just going to convert some of these to radians, some of the degrees to radians. So 0 degrees, you're going to have 0 radians. All right. So if I have 90 degrees, how many radians is that going to be? 90 times pi over 180.
1 pi.
Pi over 2. Yeah, it's going to reduce down to pi over 2. So you might want to mark some of these down so you'll be able to use it to convert back and forth, because these angles are the most common ones that they use. Okay, so for 180 degrees, what is that going to be in radians? Pi, yeah. 180 times pi over 180 is just pi. So what about, do you see, now before I go on, do you see a pattern? This is pi over 2, this is pi. Can you guess what this might be?
2 over pi.
2 pi.
Okay, 2 pi. Sure, you're probably right.
So I added a half a pi here, added a half a pi here,
Oh,
add a half a pi here. What?
3 pi.
3 pi over 2. There you go. Okay, so if I add another half a pi, how many pies?
2 pi.
I'll have 2 pies. That one's,
The 2 pi over sign.
there you go. Okay, so now let's add some more angles in. Let's add some 30-degree angles all the way around. Because you know you have that 30-60 right triangle, right? So remember, these are just estimated angles. I'm not using a protractor, so forgive me if it's off. But if I go 30 degrees up and then add 30 more degrees, what would that be? 60.
Oh, got it right.
Add 30 more degrees, and what would that be? 90. Okay, so this is 30 degrees. This is 60 degrees. Let's go ahead and do the whole top part of it. I add 30 more degrees from the 90. 120, right?
Yeah.
What's 30 more degrees?
50.
And then 30 more is going to get us to the 180. So I'm going from 0 all the way to 1 complete total pi. So how many parts are there from 0 to pi that I did? I did 6, right. Okay, so let's calculate what 30 degrees would be in radians. 30 times pi over 180. What does that calculate to be?
6. Pi over 6.
Pi over 6.
Since it's 1/3 of 90 and you're adding it down, it's multiplied by 0.
So this is, think about the fraction. This is 1/6 of a pi, right? Because it's 1/6 out of the total thing. So what do you think this fraction would be? How many 6?
2 pi over 6. 1/3. 1 pi third. Pi, yeah.
2 pi over 6, which is going to simplify down to be pi over 3. Right. That's exactly right. Now what about this 90 degree?
Pi over 2. Good.
Well, it's 3 pi over 6, right? Which reduces to pi over 2. It keeps the same pattern. Okay, what about this 120? All right, 2 pi over 3, because it's going to reduce down.
See, this wasn't that hard. See,
What about this 150? 5 pi over 6.
And it's after.
You're adding a sixth every time. And so this last one is 6 pi over 6, which reduces to pi. Okay, so you guys go and finish the bottom part. You're going to finish the bottom half of it. So add on your other angles in 30-degree increments. Nope, that's what we're doing right now in class, though. Write down the degree marks, and then go back and find your radians.
what would be the 45-degree ratio?
We're going to go back and do that in a second.
Was it 40?
Hey, did we already have the 5 pi over 3?
Okay, you guys good?
Yes.
So let's go back and do the 45-degree angles now. When you guys are ready.
I'm ready.
Okay, so your 45-degree angles are right in the middle of each quadrant. It just splits each quadrant in half. So I'm going to do that in red so it'll show up a little bit better. It's going to be right in between the two 60-degree angles. And I'm going to do just the top half this time.
And this one, this one actually splits 4.
Okay, you guys already got there. So how many parts am I dividing this into? 4. I have 1 part, there's 2 parts right there, there's 3 parts, and then that's 4 parts. So my radian here, 1/4 pi, or pi over 4. 90 degrees is 2 pi over 4, which reduces to pi over 2. What about this angle? What is the measure, first of all?
Well,
What's the angle degree?
135.
135. And what is it in radians?
3 pi over 4. This one.
And then your 180 will be 4 pi over 4, which would reduce to pi. That's right. So go ahead and finish the bottom half of the circle. There. And there you have your unit circle. So this would be a good reference for you to go back to whenever you're trying to convert back and forth, because these angles, you do use them a lot in trig. Okay, so let's work this last problem, and then I have a worksheet for you to do. So the arc length formula is in the box. Is everybody finished with this? It is S equals R times theta. Okay, so your angle is theta, and that has to be in radians when you use this equation. R is the radius of the circle, and S is the arc length. And for the example 5, it says a circle has a diameter of 9 centimeters. So let's draw a circle first of all. Here's the center. Here's your diameter, and that is 9 centimeters. Find the arc length if the central angle is 60 degrees. So central angle has to have the vertex in the center, and it's 60 degrees. So they want you to find the length of this portion of the circle. Right there. Okay, so first I need to convert that 60 degrees into radians. So looking off of your unit circle, how many radians is 60 degrees? Pi over 3.
Yeah.
Okay, so my arc length is going to be pi over 3 times what?
4.5.
Right, the radius, which is 4.5. So the way that you should type this into your calculator is using the pi button that's on your key, on the second function key, right above your caret. Okay, so you're going to press second pi divide by 3 and get that value. Don't round it until the very end so you'll get the most accurate answer. So then you're going to take that decimal times 4.5, and that's going to give you your answer. So your arc length is I guess I should use the estimating symbol, 4.7 centimeters. Go ahead and put the unit of measure down, since they give that to you.